Hi, my name is Vinh, and my partner Ridge is filming right now. And both of us worked with Professor Taufik, and for the Cal Poly Summer Undergraduate Research, we worked with buck converters and spread spectrum modulation. Spread spectrum modulation is basically a different way of reducing EMI or electromagnetic noise. So in buck converters, in order to reach the desired output, the switches will switch at a certain frequency, and this frequency will cause large peaks at that large peaks of noise at that switching frequency. So some way that some people have figured out to get rid of the EMI is to change that switching frequency, which is why it's called spread spectrum modulation, and basically means that we modulate the frequency at which the buck converter is switching, and that theoretically does reduce EMI. Well, spread spectrum is not new to buck converters. However, though a lot of research has been done for single buck converters, there's not been a lot of research done for parallel buck converters, which is what our project is.
For testing purposes, we looked at two cases of spread spectrum with asynchronous modulation and synchronous modulation with the boards. Meaning for synchronous modulation, we would run them at the same switching frequency and modulate the spectrum at the same time. And you can see here an example of the synchronous setup. We have the same modulation coming from a function generator, single channel. For asynchronous, we would use two outputs from a dual channel. You can see we have it running at a full load of 1 amp at 8 volts with the spectrum having a nice uniform spread from what it should be. And as you can see, when compared to no modulation, the synchronous modulation does a very good job of lowering the peaks and spreading the spectrum as it should. And even when compared to asynchronous modulation, the synchronous modulation does a much better job of lowering the peaks than asynchronous. And we even found in our research that as a whole, synchronous modulation does a much better job of reducing EMI than asynchronous.
We'd like to thank the College of Engineering for providing us this opportunity to work with SERP. We'd also like to thank the Department of Electrical Engineering for supporting our project. We'd also like to thank Texas Instruments for donating the boards that were used during this project. And lastly, we'd like to thank our faculty advisor, Professor Taufik, for his help and guidance during this project.